Audio Jungle.
Hello everyone, welcome to my new video. Today I will show you how to configure BGP route reflector in Juniper routers. As you can see here in our lab, we have two different autonomous systems. So before make configuration, need to know what is the route reflector and what's benefits of the route reflector. In IBGP rules, we have IBGP split horizon. So what does mean about the IBGP split horizon? In IBGP, so for example, we have this router receive the networks of 14 and 15 and 55, this one, okay, will advertise to this router, but in the IBGP split horizon to avoid the loop, so here will not be advertised to this router. So here we have two solutions. The solution number one, to use the full mesh, but the problem of the full mesh is increase the number of TCP. So this is not solution in the service provider when we have many routers. So in this case, we will use the second solution called the route reflector. So what does mean the route reflector? So the idea for use the route reflector when this router receive these three networks 14 and 15 and 55 will advertise to this router, and this router will act as a route reflector with will reflect these routes to these neighbors. Okay, so this is the idea about how enable or how route reflector can be work. So let's start to make the configuration of the route reflector. But before I didn't do nothing. So first of all, need to configure the IP, also configure the OSPF, configure the BGP external and BGP internal. Then we will enable the route reflector. So let's start with the first router. So need to access in the first router, okay, this one. Okay, so set interface loopback 0, okay, unit 0, family inet address 1111/32, and also we have the set interface for 10.0.0.1/30. Need here to change the interface name giga005. okay, also need to configure the set protocol or before routing option. Okay, routing option. So here routing option, I will give the router ID. The router ID here I will use 1111, the loopback, and also need to configure the autonomous system for this this router. Autonomous system. Okay, the autonomous system here we use the 100. Okay, then we'll enable the protocol, the OSPF. Need to configure the OSPF area 000, interface giga005, okay, and the loopback 0. Let's do just these commands. Okay, let's move to second router. Second router will do the same configuration. Set interface loopback 0, unit 0, family inet address. The address is here 222/32. Also need to configure the physical IP is 11.0.0.1, okay, and the interface name, what is that, is giga004, okay, giga004. Then set routing option, router ID, we'll use the loopback also, and need to mention also the autonomous system. Okay, autonomous system is same 100, and enable the OSPF area 000, interface giga005, and sorry, not giga05, need to delete it. Sorry, we use the 4. Okay, giga004 And also what's the problem? Yes, didn't type the set. Okay, and the loopback 0, then commit. It's okay. Now let's move to third router. Set interface loopback 0 unit 0 family inet address with 333/32. Okay, set interface giga 005 or just like this 30. Okay, and here we have 10.0.0.2, and for the interface name here we use giga 005. Okay, and also here 11.0.0.2, but here we have giga 0.0.4, and the last interface is giga 0.0.3. Okay, with IP 12.0.0.1. okay, after that need to set routing option. Okay, routing option, router ID is 333. Okay, and mention also the autonomous system here is 100. Okay, and enable the OSPF. Okay, with area 00. Interface, which interface? Giga 005, giga 004, giga 003, and loopback 0, then commit. It's okay. Now let's move to fourth router. Here is PE, our provider 8. So here we'll set interface loopback 0, set interface loopback 0 family unit 0 family inet address. So what's the address is 444/32, and also set interface 30. Okay, with 12.0.0.2, and here need to change the interface to giga 0.0.5. Okay, 0.0.5. It's okay. Now also set interface with this giga 0.0.4 is 13.1. okay, 4. Okay, let's now to configure the router ID, routing option, router ID is 444. Okay, and the autonomous system is 100. Okay, and enable the OSPF area 00, interface, which interface? Loopback 0, and only giga 0.0.5 because internal. Okay, we have here the external. Okay, then commit. Let's now move to the last router in the autonomy system 200. Okay, set interface giga 00 loopback. Let's start with loopback unit 0 family inet address 555/32, and what, and 30 here with 13.0.0.2 with physical interface giga 0.0.4. Okay, let's now imagine we have also I need to configure in the giga 0.0.5. I need to configure 14.0.0.1, and on interface giga 0.0.3 we will configure 15.0.0.1. okay, in the interface giga 0.0.3. okay, then commit. So now all configuration are okay, and the protocol OSPF is okay. So let's check here in the router 4 can see 33, 11 and 22 by what? By the OSPF. Run show root. as you can see here, I can see 111, 222, 333 by the OSPF, okay, by OSPF. So there is no problem. So now what we will do, we'll configure the IBGP, okay, the IBGP or the internal BGP. So let's start. But here in our scenario, we will not use the full mesh, because when we use the full mesh, we'll make from this R4, we will use the neighborship between router 4 and RR, and router 4 with router 1, and router 4 with router 2, and also router 2 with RR, router 2 with R4, and router 2 with R1. So we will not use, so just we will use the BGP neighborship, IBGP neighborship, R4 with RR, and RR with R1, and RR with R2. That's it. Okay, so let's access to this router. So first of all, what we do, set protocol BGP. So already we mentioned the autonomous system. So now we will set protocol BGP group. So I will give a name IBGP, okay, IBGP group, okay, and then type, which type? Internal, okay, the type is internal. Then I will mention the neighbor. What's my neighbor? The neighbor is 333, okay, in the peer autonomous system 100, okay, peer autonomous system. And here need to mention also the local address if you want. The local address, I'm using the loopback 444, okay, then commit. That's it for this router, okay. So let's move to second router in the RR, okay. Set protocol BGP with group IBGP, okay, type internal, okay, internal, and also the neighbor, our neighbor, we have here, we have two neighbor, we have 111, okay, peer autonomous system is 100, okay, and you have also here local address is 333, and also we have here the 22, the neighbor 22, the same autonomous system, and here the same local address. Let's just here to change, okay, it's okay with this router. And also with 444, with 44, okay, and in autonomous system 100, okay. That's it for this router, okay. What we'll do with this router, I make a neighborship between R4, R1, R2. Let's now move to the R1, okay. R1, same configuration, set protocol BGP group IBGP, okay, IBGP, type internal, internal, okay, and here the neighbor, what is it, is 333 in per has 100, okay, and here we have the local address is 111, local address 111, okay, then commit. That's all for this router. And also need to configure here set protocol BGP with group IBGP, type internal, okay, and peer autonomous system, what is it, is 333, peer autonomous system, sorry, here the neighbor, it's 333, peer autonomous system 100, and here local address, what is it, is 222, then commit. So now let's check the intermediate router to see all BGP are up, okay. How can check? So we do run show BGP summary, okay. As you can see, we have 2 states is up, we have the third one not yet, 22. Let's just wait, we'll see it is up now, is up, the states is up now. So all IBGP is okay now. So let's do now what we will configure. We will configure the external BGP or the eBGP. So let's do in this router. First of all, because we need to configure the TTL number, because I will do the neighborship between the two loopbacks. Okay, so what we will do, so we'll enable set protocol BGP, but here is different group eBGP. Okay, eBGP or external BGP, type external. Okay, the type is external. So I will give my neighbor is, what is it? Neighbor is 555. Okay, with per autonomous system is 200. Okay, 200. And also I will mention the local address is 444. Okay, but here when we use the loopback, need to increase the TTL number. So what we will do, the neighbor 55, I think we have the command, 1 minute, the command multi-hop. Okay, multi-hop TTL with 2 is okay now. After that, because I can't see the 55 in the routing table, if you now check the routing table, run show route, you cannot see the 555. So here you need to make also the static route. So let's do the static route here. So I will do set routing option. Okay, static route to 555. If you want to go to 555/32, you need to go to the next hop. What is the next hop? Is 13002. Okay, then now commit. Let's do the same thing to the second router, or the second router in autonomous system 200. So let's do set protocol BGP group external BGP. Okay, type external. Okay, then what? The neighbor is 444. Okay, per autonomous system 100. Okay, then we have also what is we have. So now also need to do the local address. The local address is 555. And the multi-hop is to TTL multi-hop with TTL 2. Okay, then need to configure the static route to see the 444. Static routing option, static route. If you want to go to 444/32, need to go to the next hop 13001. Okay, then commit. Now need to check if the external BGP is up or not. Run show route. Okay, run show route, or sorry, run show BGP summary. Okay, so if you check now, so all are okay. So the neighborship with 44 is up. Okay, as you can see now. So what we will do now, if you checking now here, if you can see 14 and 15 by BGP or not, as you can see, you cannot see anything. So what we will do, I will set to this router, will make a route policy to advertise what, or export the direct route. Okay, the direct route. Let's do now. If you do now show or set policy statement, I will BGP or I said export direct, like this, direct. Okay, term one from protocol what? From protocol direct. Okay, then accept. Okay, then I will apply under the BGP. Set protocol BGP group Ibgp eBGP export. What export this policy eDirect. Okay, direct. Okay, then commit. Let's see now. Normally now I can see 14 and 15 by BGP from this router. Let's check now. Run show route. Okay, so I can see 14 and 15 by what? By the BGP, by Protocol Bgp. So let's now to check here. Let's now to check in this router if I can see or not. Run show route. So now here you cannot see nothing. Okay, you cannot see nothing. Okay, let's move now to see the advertised and receiving routes from this router by using this command. Run show route receiving protocol BGP from 555. What I receive from this, I receive these ones, okay, 13, 14, 15, okay, by 55. Let's do the same comment. What can advertise to what? Advertise protocol BGP to 555. So I advertise nothing. Okay, let's do with 333 what I advertised. 333, 14 and 15, but we cannot see it. So why he cannot see it? If you go now to this router, to our router, if you now check run show route, first of all run show route, I cannot see the 14 and 15. Let's do the same command. Run show receiving or route receiving protocol BGP from what? From 444. I cannot receive anything. Okay, so what we need to do now, we need to do the next hop self to see these routes. Okay, to see these routes. Now let's go to this router and enable set. Need to create policy statement next hop term 1, then next hop self, then accept, then apply it. Set BG protocol BGP group Ibgp, we'll apply it in the internal BGP. Export what we export the next hop. Okay, and commit. If you now check here, same command 4333. Now I can receive by self like this 111 222 333, as you can see. Now if you go to the router RR or the reflector, run show routes. Now I can see the 14 and 15 by BGP, you see. But now let's move to these two routers if can receive or not. Run show route. I cannot receive the BGP here, and let's check here also. Run show routes. We cannot receive. Why? Because this is the Ibgp split horizon rule. I cannot advertise to our neighbors. So in this case, I will configure this router to a router reflector to reflect all the routes received from external to these two routers. So how can we do? So let's access to our router. So need to set protocol BGP, okay, group Ibgp, okay, Ibgp with neighbor. Our neighbor, what is it? The neighbor is 1111, okay. Then I will type the cluster. The cluster, it means this is the router or RR server, okay, and other is client. So RR server is 333, and the same command to the neighbor 222, then commit. So let's now to check if these two routers receive these routes 14 and 15 or not. Let's access to first router and do run show route. Okay, not yet. Okay, let's wait. Not applied. Yes, exactly. Now I can receive 14 and 15 from what? From the the RR router. Also need to here to check run show route to see if receive or not. I can also receive 14 and 15 by BGP. So this is all how can configure route reflector in Juniper router. Thank you so much for your watching and consideration. Don't forget to subscribe my channel